This video is about models, and let's look at the current equations again. Again, these three equations describe the behavior of a transistor. These are the MOSFET equations again. And let's see, if we're mostly interested in this equation down at the bottom here. To use this equation, you need power, the value of Kp, you need the value of VTP, and you need the value of lambda. While you're operating this, VGS and VDS will change. Those are things that have to do with the, how you have the circuit set up, but not intrinsic to the transistor. But lambda, VT, and K prime, those are intrinsic to the transistor. So those values need to come from someplace, and every transistor you'll use, if you get a transistor even with the same name from a different company, those values might be a little bit different. So if you want to simulate before you build something, you want to have those transistors in simulation behave like the transistors you're going to use in the actual thing that you build. So what you do is you can go to the model file. Now this is a model file for the transistors that we used in the VLSI class. VLSI is very large scale integrated circuits, and that just means they're circuits made with a lot of transistors. And in that class, we actually were going to fabricate chips. Some things happened politically with our relationship with China, so we can't fabricate chips at this time, but this is the model file, and they give us a very accurate model file because each time you fabricate a chip, that's $10,000, $100,000, $1 million that you're spending to have this chip fabricated. You want to make sure when it comes back after 3 months that it actually works. So the model is very accurate. And if you look at this model, there's here's version equals, that's not anything important, level equals, then there's this TNOM equals, TOX equals, VTHO equals, NCH, is that an H? Can't really, N channel, makes sense, XJ equals, everywhere there's an equal sign, they're setting a value to, don't really want to call it a variable, but the equation that the simulator uses to simulate your transistors is not this equation. This equation just needs 3 values. The equation that you use when you're using this model has an equation that uses all of these values. So maybe 100 different values that you need to plug into the equation to get your current output. And this is for the PMOS over here. So model files give you the detailed information about your transistors, and every time you use a different transistor, you want to get the model file appropriate to that transistor, or else you won't get an accurate simulation. So that's for the MOSFETs. Let's see, for BJTs, I should have... So for BJTs, you've got this equation right here. And if you go and you look at model file for that, again, you've got all these equal signs. I forgot what I was saying, but the dogs are now quiet, so I'll try this again. But yeah, this is just for a BJT. And for the BJT equation, you need the saturation current, you need the early voltage. You just need really 2 values here to use this equation. And that's because it's the equation's been made to be human friendly. But if you simulate, the equation that the simulator actually uses needs all of these values to get an accurate current approximation. And that's what I should have said. Here is also for the MOSFET. The equation for the MOSFET's been simplified, so it's easy for us to use to make simple calculations. But the equation is is an approximation, and there's an actual design step, well-known design step, where you do calculations by hand using this equation, and that's not going to be, absolutely accurate. It's going to be close, but not right on. And then you put it into the simulator, you put your circuit into the simulator, and you see how it behaves. And if it doesn't behave quite right, you do that last design step, which is called tweaking. So you tweak your design until the simulator says it's right, because the simulator is actually using really complicated and accurate equations to find the current for you.